Today we're doing section 2-7 of our handout. This is nomenclature that involves double bonds, alkenes. The first diagram we have is a cyclohexene, and we begin by naming it, by numbering it, so we can give the substituents the proper numbers. Wherever the double bond is the highest priority when the only other substituents are alkyl groups. So we name it 1-ethyl because the double bond starts here, and we number it through the double bond. We never number it the other way around. We always number through the double bond. So the first position is ethyl, and then at the third position we have a methyl, and also at the fourth. So it's 1-ethyl, 3,4-dimethyl cyclohexene. The second diagram, we name it as a propene with 2 cyclobutyl substituents. Now, whenever you have a double bond, there's the possibility that you have unequal groups attached to the double bond. Whenever that happens, there's the possibility of cis-trans isomerism, and this is one case of that. Here we have a propene skeleton with the cyclobutyls both on the same side, so we're going to call that cis 1,3 dicyclobutyl propene. Here they're on opposite sides, so it'll be called trans dicyclobutyl propene. C, again, is the same thing, except there are 2 double bonds in C. The longest continuous chain that includes the double bonds is a pentane. What's a pentadiene, because there are 2 double bonds, and they're at the first and third position. I was looking at how to number it, and at first I wanted to number it from this side, saying 1, 2, 3, 4, 5, but then I realized that would give 2, 4 to the numbering of the alkene, so it's better to have 1, 3. And then everything else is a substituent. This is a substituent, and this is a substituent. So we call it 4-cyclopentyl, 3-methyl, 1,3-pentadiene. Now, because there are 2 double bonds, one of them is capable of being asymmetrical. This one has 2 hydrogen atoms, so flipping them over doesn't produce any change, so this is not susceptible to cis-trans isomerism. The second bond is, on the other hand. So this is the trans version of the molecule, where we have the 2 heaviest groups on opposite sides of the double bond, this being the double bond that is cis or trans. So we call this trans 4-cyclopentyl 3-methyl 1,3-pentadiene. The fourth example, D, was drawn like this initially, so I redrew it in bond line notation, and then it makes it easier to see what the longest continuous chain of carbon atoms is. 1, 2, 3, 4, 5, 6. So it's going to be named as a hexene. There's 1 double bond at the third position, and these are methyl substituents. So we call it trans, in this case, 2,2,5,5 tetramethyl 3-hexene. And if the 2 heavier substituents on the double bond are on the same side, then we call it cis, same name. And again, recall that trans is the same as E for Entgegen, and cis is the same as Z for zusammen. Either way. You can also, instead of writing the full word trans, write an italicized T. And same with, instead of writing the whole word cis, you can write simply C. And that reduces it to 1 letter, makes the name more compact. In E, we have this molecule, which was tricky to name, because whenever you name molecules that contain double bonds, you have to pick the longest chain that includes the double bond. It's tempting here to look at this chain, because that would be the longest continuous chain, but it would exclude the double bond. So we have to name this one as the skeleton of the molecule. So I redrew it with that skeleton straight, and these other parts as the substituents, and that's what it looks like. So you see that it's a pentane skeleton with 2 double bonds, so it's a pentadiene. That's reflected here, 1,4-pentadiene. I started numbering from this side because that gives these substituents the lowest possible numbering. This is an isopropyl group. This is a butyl chain that's been substituted with 2 methyl groups at the third position. So we end up naming it 2-isopropyl, 3 open bracket, it's a butyl group with 2 methyl, so it's 3,3-dimethyl butyl. Close the bracket. 1,4-pentadiene. If you were to rename it without using the trivial name isopropyl, then you'd have to say 1-methylethyl. See, it's an ethyl group with a methyl substituent on it. And then you'd have to say that's at the second position. So you'd say 2 open bracket, 1-methylethyl, close bracket, and then you name the rest of the molecule. F is probably the trickiest one in the series. It shows a molecule that has to be redrawn with the longest chain containing the most number of double bonds. It ends up being substituted by a vinyl at the 4th position. So we call it 4-vinyl 2,4-heptadiene. So it's got a 7-carbon chain. Because you have 2 double bonds that are susceptible of cis-trans isomerism, it creates 4 different possibilities. You can have trans-trans, cis-trans, cis-cis, or trans-cis. All 4 of these molecules will have different chemical properties, and the nuance in the naming of the structures has to be acknowledged if you truly want to name them properly. Very often, textbooks will stop here. They'll just say, we'll name the molecule, we can say that part, and that's correct, but this other detail should not be neglected. And I just recall to you that these trivial groups occur with enough frequency that it's a good idea to memorize them. A vinyl group, allele group, and a propenyl group. Lastly, we have benzene. Benzene is a compound that has 3 double bonds and cyclic. Because electrons are moving at roughly 2/3 the speed of light, their position is average. These double bonds are constantly moving, so that benzene has a property that we call aromaticity. There's a stability associated with 3 conjugated double bonds within a ring. This molecule is harder to hydrogenate than, say, an open chain triene. And the way they illustrate normally the movement of these double bonds is to simply draw a circle in the center of the benzene ring. Whenever you have di-substituted benzene, you have a special name for each type of substitution. If it's 1,2 substituted, it's called ortho. Here we have xylene. Xylene is a benzene ring with 2 methyl groups on it. It's the solvent they use in permanent markers. So this would be called orthoxylene. If one of the methyl groups is shifted down so it's a 1,3 substituted, then it becomes metaxylene. And if it's 1,4 substituted, it's called paraxylene. Just as a matter of interest, para-dichlorobenzene, see it's disubstituted with chlorine, is the substance they use in urinal mints to disinfect and to deodorize. The last 2 answers are a butyl group substituted on benzene. It's called butylbenzene. And here we have a toluene, which is a benzene with a methyl group on it, and then it's substituted, meta substituted with an ethyl group, so we call it meta-ethyltoluene. Typically, you will see methyl benzene. You'll never see it named that way. Most of the time, chemists will refer to the trivial name, which is toluene. Methyl benzene is also known as toluene.